Good evening.
Good evening, sir.
Good evening, sir.
Hear me? Can you hear me?
Yes, we can hear you.
Yeah. Uh, Today, that is the topic what we are going to call today. I will share with your presentation. Wait a minute then. Hope you can see. Hope you can see now. Can you see that? Can you see that? Can you see that?
Yes, sir, we can see.
Yeah. Now, the first topic that today you are going to using engineering. This may be a 1 hour lecture. Engineering practices. In the first slide I will choose that as engineering is the defining engineering is a profession. Now you know that you can define it your own way, but I took this from somewhere. So it is the profession. It is a profession in which knowledge of mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. Right. Now, it is now, if you go through this definition, you can get the blended view and the essence of that is definition. It is said mathematical and natural sciences. The mathematical and natural sciences. Because it means natural sciences. What are the natural sciences? We know the physics, geography, bio, chemistry, geology. You can consider those are the natural sciences. But you will give some mathematical and natural sciences that is gained by study, experience, and practice. That is gained by study, experience, and practice. So you want to study first, then you will have to get the experience and you have to practice it and apply it with judgment. When you have many alternatives, you have a judgment. Develop or solve or resolve ways to utilize economically viable and technically feasible solution. Either for the benefit of mankind, you can change it even many for the living kind. In the more broader sense. So it means when you want to be an engineer, right? And what are the attributes you require? You require study. You are required to study. And you have to get to exposure, that's our experience. And you have to practice it. Then you have to, then it is applied, applicability. And you heard judgment. You have to judge that what is really what kind of that is it is a judgment you require. When there are a lot of choices, then you have to judge that this is a combination of the choices, so that, or sometimes you want to go for the investigative purpose, that is required. So it means, for example, now today, as electrical engineers, that is, we learn electrical machines. Now, the machine is connected to a system as a motor. The motor will be used for the traction purpose and continuous running purpose. Right? Apply for a load to have a rotation. Right? Then you should, first thing you should know that what is the machine and what is the motor. That is why you will study that motor, the principles of the motor, what is the underlying philosophy. Underlying philosophy used to study a motor. We know electromagnetism, Lenz's law, and Fleming's left-hand rule, Ohm's law, Kirchhoff's law, we apply to study a motor, how to speed up motor, how to control its speed, and how it is applied. We do some practicals in universities. We study those things through our courseworks, through lectures, reading books, etc. Now, when it comes to the industrial training, we will get little exposure, technical exposure, how those are applied. And when we practice, we know we have to use that is proper application it. Where that is a series motor is used, how the speed of the shunt motor is controlled, And when you want traction, you'll use it. Uh, that means high torque, an initial high current. And how to apply the dynamic braking for a motor? How to reverse the direction of the motor? So those things and judgment. Judgment means when you want to buy a motor, you have to call quotations, you evaluate technical specifications, you decide what is economically viable and technically feasible. So finally, that comes through your study experience and practice. When you apply for it, then you can have a right solution. So all these processes, when you are combined, we call it is engineering profession. It involves decision making through your knowledge and experience to handle complex problems. In engineering, there are three kinds of problems. One is complex engineering problems. Another one is broadly defined problems. And another one is a simply defined problems. The broadly defined, complex, that is the complex problems, broadly defined problems, and simply defined problems. The complex engineering problems, to do that, you need the expertise, knowledge, you need mathematical modeling, and you use the natural sciences, and you get the proper experience, and you have to practice it, and you have the judgmental skills, leadership skills, including decision making, your conduct, and everything. So there's a highest level of competency is how can I say it is a highest level of competence in engineering profession. We grade it as chartered engineer once you reach for that, because that is why in a child, when you become a chartered engineer, the first thing you need that your knowledge. That is your knowledge you will get from the university degree, 4-year engineering degree. 4-year engineering degree. In 4-year engineering degree, that is nowadays it consists minimum 8 semesters with 6 months industrial training program. So in terms of credit, we can say minimum 130 credits. This 130 credits, you will get the 25 credits from mathematical and engineering sciences. It means you test your mathematical knowledge and engineering science, such as engineering chemistry and engineering physics. So that component covers 25. So another 75 you will get your core component. It means the core in-depth knowledge in your specialty. For example, in case of civil engineering, you want to have that structural engineering in-depth knowledge, and you want to have knowledge in fluid, water resources. That is why we study fluid mechanics, and strength of materials, material sciences, environmental sciences, and engineering design part. It covers 75, 25 plus 75 is 100. So balance minimum 130 will cover from management part, or called is humanities, that how that is a labor laws, and how you behave in the society, etc. Then according, that is the structure. Then it divided into 8 semesters. These 8 semesters, you have some modules. These modules are interlinked with each other. We cannot go into higher semester, higher module, without following a lower module, because one module, learning outcome of one module is linked with input for the other module. So that is why you have to that the program should be structured in a way that finally the minimum 130 hours will be delivered. Minimum 130 hours will be delivered, and giving 6 months training as 24 weeks to gain your exposure, that part. Then after that, following through this kind of program, you will end up with that you will be able to resolve complex engineering problems. Sorry, you will be able to start your career to resolve complex engineering problems. But still, you need more experience. And you need further training. So then after that, that is why you will expose to industry, and it requires minimum 2 years, 24 weeks recognized training, and another 24 weeks at experience. So finally, those you will be completed, you will have to show your competencies. That is why we have developed a PR exercise. It means it evaluates first. You have followed the 4-year recognized degree or accredited degree, and whether you have undergone a training period under a chartered engineer. After that, you have taken your responsible experience. So then you will be eligible to apply for PR exercise. Then we test your knowledge, whether you are ready to face the management issues through the B paper, And after that, after a little bit matured, we want to test that through Viva. You are able to resolve complex engineering problems. So then this is the highest position in any engineering profession, highest rank in engineering profession. We call it as chartered teacher. In Sri Lanka, recently passed Act Sri Lanka Act number 17 of 2017. That act says that any engineering practitioner to practice engineering, practitioners categories have been defined the 5 categories, 6 categories. The highest category is chartered teacher. So to become a chartered engineer, it says you must be must be a member of Institution of Engineering Sri Lanka, corporate member. Then only you can apply for registration. Therefore, Sri Lanka Engineering Council Act, known as the ECSL Act, it clearly says you must be a corporate member of IS, which means that corporate, unless you are a corporate member, you cannot practice as a chartered teacher. If someone is engaged in engineering practice and designated as chartered engineer, but without getting these qualifications, that he can be punished under the law. Because chartered engineer is the word, the protected word through Sri Lanka, so through Engineering Council Sri Lanka Act. Right. Now, we know that this slide I will share with you all. It further describes something about engineer versus scientist. The scientist discovers the theories like the Archimedes principle, the scientist. Whereas engineer innovates solutions. Kindly note that engineers are dealing with more solutions rather than searching for more theories. Because people need solutions. Now, people need solutions. For example, now the concept of high-rise buildings. We know when population is grown, population is ever increasing. When population is ever increasing, but the land and extent is limited, then you must think of giving a solution for this issue. So that is why you, when you use the skyscrapers, high-rise buildings, that came as a solution. That came as a solution. Right? Now, we know now that it's a internet. That before internet was begin, everyone was working in isolation. Everyone working as an isolation. So in isolation, when you work as in isolation, in, everyone is working as isolation. Working as an isolation. There was a need that talk one computer to another computer rather than exchanging the floppy disk and carrying the floppy disks or hard disks. So in data communication, solution found. You can communicate. You can communicate data. You can communicate data among computers. Initially, it was limited to a company. Finally, it has reached to global, giving name to internet. That because the internet solve it actually it finds solution, it gives a solution. It gives a solution. So that solution enable us to develop more applications. So it means you can transfer the data and information from one account to the another account. That has created our life is more comfortable. For example, banking transaction. Actually, it is a solution. That we know people in general living together in community. They demand goods and services with following values as deliverables. Safety and security. And they expect standards. So, engineers shall be able to give these, provide these solutions. Provide the solution. Provide the solution to whom? Provide the solutions to people. That people expect the solution should be reliable. And it should be safe and secure. And they expect the standards to be followed. And it should be economically viable and financially feasible. Right. Now the slide shows the competencies required to become a child teacher. Number one is that we test that understanding, the knowledge and understanding of engineering principles that you will get from your learning in the university, studying. Design and development process, system, service, and products. This is another competence. And your responsibility, how responsible you are, how accountable you are, giving leadership, and communication and interpersonal skills, professional commitments. So this first competence you can get at the point of you will pass out from universities. And these others you will gain through your industrial exposure. Now I explain why that is number one is required. Now, second one is a design, development, and process system service and production. So you have to, you must be able to design and development of sometimes processes and systems. You know, in case of civil engineering, you are a structural, that is, you will design. In case of electrical engineers also, you will involve in the design, and you are talking about more in systems. In computer engineering, of course, you use mostly the process and systems. And the important thing is responsibility that comes to your experience. By appointing you are an engineer, you will be held responsible. You will be held responsible. You will be held responsible. And you should drive your team. That for that you need leadership traits. You must need leadership traits. It comes through your experience. Some leaders are inborn, but they'll have to develop those skills. Because once you are appointed as an engineer, you are working a team. You are a spokesman. You are not only the spokesman. You are their representative. That you should guide them. You should coach them. Finally, that is a team spirit you should build up. You have to work with peons, drivers, unskilled laborers, skilled workmen, supervisors, and customer care officers, etc. You have to work with engineering and non-engineering people. But for them, you are a leader. How you can use your leadership skills in a team. You must be a very good team player. You must be a good mentor for them. And the communication and interpersonal skills. The communication is very important. In communication, it says, you have to communicate precisely, maintaining the clarity. That is the effective communication. In here, there is some people that is this is wrongly interpreted or misinterpreted. That communication means writing in the very good English or very good Sinhala, using your literature, or others could not understand. the way that others could not understand. It is not that way. But of course, you need grammatically correct. Otherwise, that is a meaning be getting distorted. Communication and interpersonal skills. When you communicate something, even verbal, even in writing, it should be very precise. It should be very highly objective. And it clearly address your requirement. Etc. And your professional commitment. You must engage in the work, your commitment to uplift your profession and society, which means you have to commit. Professional commitment covers, that is your discipline, covers the code of ethics, it covers other standards, especially code of ethics and conduct. And it is not limited to that. That you must do some volunteer work to uplift the values of the profession. So those are the things you have to understand. Now, here I have, this is I have already described. And this is, of course, a little bit expanded version. Now, this is should place a priority on public safety and interest over the others. Now, this is a key responsibility and a function. This is public safety is very important. In international standards, it says engineering profession should place priority on public safety. For example, when you work along the road, now say you are a civil engineer working in the road development. How many potholes in the road? Sometimes very deep canals, unprotected. That you know, it imposing a possible danger for the innocent people who are going here and there. Sometimes some poles are planted middle side of the road. That may cause a lot of accidents. And sometimes even when you work with a team, your team may be that is electricians under you. They work without safety helmets or without safety gloves and without insulated spanners. So this is your responsibility. have to ensure that safety is number one. It means the safety first principle. And accountable for the conduct of well-being of the others and the society where they work on society. So you must think of others. Others are laymen, they don't have that knowledge. If some wires are crossing with a lower height, people may touch and get electrocuted. Right in here. It is another social responsibilities. That is one of our function and responsibility. Ensure the safety and well-being of the public. And more important, the society funds and resources. In this world, resources are not unlimited. Resources are limited. Right. So if you consume the resources through your applications unnecessarily, so it is really a problem for the living kind. Right. And you have to be, I will tell a little bit, but you must be able to, I don't know whether how practical it is, blowing the whistle on illegality or wrongdoing. Those are some social responsibilities. So that is engineers, and especially your social responsibility means you have to be very objective. Then we view that always you do the right thing to society. When you are attached to work somewhere, that is called, another word is conflict of interest. When you select that is particular company as your contract, that particular company that is your next of kin's place, this is your conflict of interest. You have to declare that first. Those are general things. So there are a lot of things I have written in here, right? And here the commitment of risk assessment expert to ethical risk safety assessment. When you start, before starting work, always you must think of environmental factors, proper assessment, environmental impact assessment you have done, and the precautionary principle, and abiding by the principle of sustainable developments. Those are the things you'll have to write. Now, yeah, I will skip it beside. Now, when you, that is rules of conduct, this has been clearly indicated in our bylaws. Any engineer shall at all times uphold the dignity and reputation of their profession. You will have to act with fairness, integrity towards everyone with whom their work is connected. And the highlighted words are public interest, health, safety, and environment. Those are the keywords. You have to act with fairness and integrity. And you have to safeguard the public interest, health, safety, and the environment in the matters. Those things you will have to. So for example, how fair you are doing the work when you do the project. That is particularly if you fix a generator in the project. Is a generator out manifold or generator exhaust, generator silence issue, they want to release that is a carbon monoxide or carbon dioxide. The exhaust pipe, if you put in the direction of the hospital nearby, is it fair? No. Another thing, knowing that some materials are coming from particular company that is a friend of yours, that knowing that material is defective, if you order someone you are working under you to accept it without following standards, is it fair? Unfair. It lost your integrity. So, in other words, we are missing. It means you are at least you should not prejudiced. And you should be unbiased. Shouldn't be prejudiced and you unbiased. And finally, your aim is that you have worked with the public interest. Health, safety, and environment are the key values. Right. Now in here, I want to skip this one. Now, I want to come here that as a what is the role? The most of the people will get confused. That is the role and the responsibility. Here the role. Role of engineer means engineer kenek vidira ragapana charithe kumar. What is your role there? In a movie, it may be one person can act as a villain. The next one he can act as a hero. Now, in actually, what is the role of an engineer? As I said, he act as manager or leader. We here calling the managerial leader is the best word. So you have to play the managerial role and representative. For example, if you are working as a district engineer in a particular, let's say, what about the RDA? That is, you are a representative. You are a representative of that particular company in your area. There is a public see you as you are the representative. So any person working under you did the mistake, or you did the mistake, they come and complain to you. You are the representative. You cannot say that is not I am responsible. You are also responsible. You are not personally accountable, but you are responsible. And then you must be a very good motivator. As I said, most of engineers, they work with a team. Sometimes somebody can argue that they are a planning man I am doing planning work, but I don't have staff. There is no need to have a staff to become a leader. When you, for example, say that when you are working in the planning, that is, you will have to work with the staff of the other people. So here you are taking a motivator role. You are leader, of course you are motivator. Because if you want to have entire building, that is the strategy for the buildings in the buildings department, you will have to get the support from all the people, all the people who are not only working under you, but in the working under some others as well. Then you should be a very good motivator. And you are a planner. You should be a planner. You should plan well, plan ahead of the task. You must have a good plan. And to have a good planning, you must be a very good planner. And he avoids spelling mistake. He said, you could be a very good decision maker. That is, you decide something every day. When it comes to work, sometimes when you ask your people, come and say, ask. That is I have the 3 vehicles today, or 5 vehicles, but only two have broken down. So you have to take an urgent decision within your financial law applicability framework, and obliging to rules and regulations. Obliging to rules and regulations. Obliging rules and regulations. You have to work. Obliging to rules and regulations. You cannot skip those things. Now, your responsibilities in case of operational aspect, you must take the responsibility. Here we call your role and responsibility. To oversee entire operations undertaken by him, and ensure that results will be timely delivered, maintaining economies of scale, adhering to safety standards, complying with regulations, optimizing resources without compromising overall quality. You can see that is a hell of a responsibility you have. Okay. Here, delivered maintaining economies, okay, adhering to safety standards, complying with regulation. Economies of scale means when you produce more and more things, providing more services, that is, you must use, that is economies of scale, rather than going from one by one. We'll have to develop the process so that is a batch production, batch processing. For example, that is you use that is a one vehicle rather than sending the three vehicles in the one direction, in the one road, the one destination. You have to think of that going one vehicle and drop the people there and go to the further, and you can manage with that. So the economies of scale, just a small example. Adhering to safety standards. Everywhere this lecture, that is another keyword is safety. Complying with regulations, optimizing the resources, but without compromising overall quality. But mostly when you are talking of complying with regulation, it says optimizing the resources. When you optimize the resources, the quality will drop too much. But there should be a balance in a way. So categories of responsibilities, I now, where the engineer plays this role as a network planning and design part and project implementation. Some engineers are working design and network planning and project implementation, O&M, research and development. And key job functions here. Now I explain your role and certain responsibilities. Now I am talking. Right? When you do that is a taking this responsibility, then what are the actions you need it? You are engaged in certain actions. You want to engage with these actions. Those are the called functions. But you have to do this function in a responsible manner to deliver your responsibilities. So planning and budgeting overall key activities. Communicate and allocate resources and assign the targets derived from the corporate goals. Planning and budgeting, that your day-to-day function, or sometimes yearly annual function. Some function you will have to do it annually, but some function you have to do weekly, etc. And communicate and allocate resources to staff. Ensure that processes are well established and apply the changes wherever necessary. Now, here the biggest problem, I think we have that is ensure that processes are well established and apply the changes wherever necessary. Allocation of resources to the staff. Sorry, there's mistake. Here, process approach is now you have to manage the process. The word process is spelled out, some people say that it is a process over the time. You need automation. Yes, automation, better to have automation, but without automation, you have process. Only thing you must do, you don't have developed the process. You have not developed the process. That is the biggest issue. The process means, for example, when you assign a task, then there is a work order management system. Then, for example, you will have to first thing initiate job. Then the cost in the initiate job. After initiating job, then you will have to plan the job. Prepare the BOQ. Approve the BOQ. Budgeting the cost in the BOQ. Allocating the budget. Then issuing the works order. Execution of the works order. Monitoring the activities. measure and pay. And A2 is that you will have to follow the quality. So this process. So if you clearly written the process, that is easy to monitor, easy to maintain total quality. Because when you measure the quality in every point, each and every process, then you can see that overall quality is managed. Right? Now, allocation of resources out to the staff. Now, and those are the key job functions. I explain it. I will share this one. And legislative requirement. Now, there are some legislative requirements that you should know to practice as engineers. One is the Engineering Council Act, and another one is ISL Act, Safety and Factory Ordinance, Industrial Dispute Act, and environmental regulations. So, I think I have covered that is all important parts about this, what is the engineering practice. The what today now, only thing is now within 5 minutes or 10 minutes time, that is there will be a power interruption in my area. So I hope that actually if you have some questions, please raise your hand. I will give 5 minutes time. Did you have any comments? Did you understand about it? Did you understand? Did you understand? Any question? Okay. Do you have any question? Now, another one part to be covered about Engineering Council Act. So, oh, sorry, that is you. Someone raise your hand. Okay, that is, they will do that recording. That is the institution will do that. Now, today, that is another lecture I want to conduct about Engineering Council Act and ISL Act. That I will do that is next week because your exam has not, the date has not yet been announced. Am I correct? That another, sorry, that is a part later perhaps. I hope you understood. You have any question, please ask. Today, that is out what you have. That after end of this lecture, you must be able to know about role of an engineer and responsibilities and role and responsibility and what are the functions. There are two things. Role is what kind of what action. What is your role? And in that role, what do you do with the functions? And your responsibility is how you are committed, for it. And when you are committed, how you are committed for it. It is a responsibility. What you do is a function. Your role, what you are doing, what your role is, that why you are assigned to that. Your role is, that is why this role, why you are there. And your function means what you are doing. Responsibility means how are you doing it? How you are committed. So that's what I want to say. So then we will go to the next lecture. That is during the coming week or next week before the exam. So thank you very much for your patience. If you have any question, please raise your hand. We may have 5 or 6 minutes. Okay.